Dr. Raghunath.
Thank you. Can everyone hear me all right at the back? Brilliant. Welcome to my talk about unleashing the magic of large language modeling with Dolly 2.0. I'm just curious, how many people in the audience have tried Dolly? Oh, well, yeah, it's good. That's good. That's impressive. Okay, the aim of today's talk really is to show you how I've used Dolly. I've used Dolly in some fun ways and some productive ways, and it's just really to share what we've done with Dolly. Hopefully, at the end of this talk, you'll be able to go away, and for those who've not tried Dolly, you'll be able to try some of the things that I've showed here in the slide today. And for those who have already tried Dolly, maybe there are some things here that you've just not tried yet. Before I go into my talk, just a quick introduction about myself. My details are there, so feel free to connect with me. If you have any questions about anything data science, machine learning, feel free to get in touch with me. I'm a principal data scientist. I work for a company called Advancing Analytics. I'm not sure whether you've heard of us, but if you have, it'll probably be because of Simon Whiteley, who's got a YouTube channel, and his jingle is "Hello Spark fans." We specialize in data engineering and machine learning. So if you wanted to know anything about Databricks or Spark or machine learning, head to our YouTube website. We've also got a fantastic podcast channel called Totally Skewed. So that was a quick introduction about myself. Every time we talk about generative AI or LLMs, people just don't understand the connection with artificial intelligence. So I just wanted to take a couple of minutes just to talk about the history of generative AI. And generative AI goes back to many, 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 many years ago. It started with artificial intelligence in the 1940s, 1950s. And artificial intelligence is a field where computers can imitate human behavior. Now, if you were to look back and look at the history, the first sign of artificial intelligence, or AI, was a computer that was developed to play checkers with us. This then evolved into machine learning, which is a subset of artificial intelligence. And machine learning uses algorithm, right? We know machine learning. It uses algorithm to learn from data, learn from patterns, and then predict. And when we go a step further than that, we've got deep learning, and it came about in 2017, where it was more complex. It went deeper. It's a subset of machine learning, like I said. It aims to use neural network architectures to process data and make decisions. Then quite recently, 2021, we've got generative AI. And that's, again, a field within deep learning. So it's a subset of deep learning that creates written, visual, and even musical content. If you give it a prompt, it uses that prompt to create output for you, which is why it's called generative AI. Now, just to give you an example of generative AI, all these images on this slide have been generated using OpenAI's Dolly's model using generative technology. So pretty impressive. Just to understand, right, what's the difference between generative AI and traditional machine learning? Let's look at traditional machine learning for a couple of minutes. If we wanted to do, say, for example, sentiment analysis, typically, if we were doing this using traditional machine learning, we would have training data. We would then create individual models to do a particular task. And this is true for a lot of other tasks. Say, for example, if you wanted to do classification, if you wanted to do entity recognition, where you've got a large corpus of text, and you wanted to recognize different entities within the text, you'd typically have separate models within traditional machine learning to do this task for you. So with generative AI, it's quite different. I've seen my little logo moved before, but the idea behind generative AI is you can feed in a large corpus of data, and that can be structured and unstructured. You go through a training phase, and like with the OpenAI model, it's been trained for months and months and months because you're feeding it tons and tons of data. And what happens then is it's tasked to do not just one task, but many, many different tasks. So on this slide, for example, if we've got a generative AI model, you can quite easily do question and answering. You can do sentiment analysis. You only need a single large language model to do a variety of tasks. So Dolly, what we're talking about today, is a large language model. And how is that different to generative AI? It's a subset of generative AI, the difference being it's trained on text input to generate text output. So when we talk about LLMs, there are lots and lots of different options. But typically, right, we've got two ways to leverage large language models. The first way being proprietary large language models, where we are pinging services like Cohere or OpenAI. And the second way to leverage large language models is to use open source models that are, a lot of them now are served in Hugging Face Hub. There's lots of pros and cons between proprietary and open source large language models. And I've got a table here that summarizes the differences between the features. But what I really wanted to draw your attention to is these 4 things that are very important for consultancy like us when we consult on LLMs. What's the differences between if you're pinging an API like OpenAI or Cohere, as opposed to using open source models? You tend to get more sophistication with OpenAI models. Although having said that, with proprietary LLMs, you tend to get more sophisticated models. Having said that, though, a lot of your open source models now are advancing at the rate that they are getting as sophisticated as OpenAI models. And you look at fast responses, for example, you generally get very quick responses because OpenAI, for example, are hosted on huge computing power backing them up, so your latency is very quick. Whereas your open source model, your performance now depends on how big of a model you're using and leveraging. Those are a difference when it comes to response times. Data residency is a big one. A lot of consultants, a lot of companies that we consult are very keen on this particular topic, in terms of how secure is their data. If you're using OpenAI, then there's an element of your data being transferred to OpenAI. If you don't understand how retraining is happening within OpenAI, although there's an option to untick that option so that your data is not being sent back for retraining. Whereas if you're using open source large language models, you've got ultimate control over your data privacy and management. Transparency is another big one. If you work in a highly regulated industry, then you'd want to understand the underlying code, you'd want to understand the weights, and you'd want to understand your training data behind how your large language models were trained. Now, you can get this with open source. You typically have your source code, your model weights, your training data are all freely available to you. So those are the differences between proprietary and open source large language models. Now, what we're going to look at is application and use cases. Even with Dolly, you can pretty much achieve a lot of this use case, from content generation, generating responses to customer inquiries. We will see later on in this presentation how we've used it in a fun way. Summarization, we've got use cases. We've worked with customers to use Dolly to summarize customer conversations. Question and answer, which is probably one of your top LLM use cases. And how we can also use large language models to do semantic search. And what I mean by semantic search is knowledge mining. Okay, in terms of all those use cases, often we get, so how would we go ahead and what steps would we need to take to implement various use cases? And there are a couple of different ways, right? First way is prompt engineering. And prompt engineering is what it says on the slide. It's an art of using natural language to get results from the model, from the large language model. Very effective way of really getting what you need from a model. But there are many different techniques, and we'll touch on that. You probably have seen this a lot of times now during the keynote where Andre Kapati said the hottest new programming language is English. And this basically reiterates the previous slide about prompt engineering, how using any language really to ultimately get something out from your large language model. One of the most effective way of implementing, for example, use cases is retrieval augmented generation, often abbreviated as RAGs. And RAGs are basically a framework that combines retrieval and how you augment your tags within the model, and then how you get accurate, relevant responses from your model. The third method is also becoming very, very popular, is fine-tuning. Fine-tuning is about adapting a pre-trained language model. So this is where you've got very focused data set, and you're looking to use a large language model to retrain all its weights to address a specific task or domain. Now, we won't be going into fine-tuning in this presentation, but we'll look at other methods in terms of how we've leveraged Dolly within Databricks to look at a few things. So when would you use prompt engineering? When would you use RAG? And when would you use fine-tuning? Often I'd say your first probably protocol is to use prompt engineering. Try different prompts and see how your large language model is responding. If you've got limited data and resources, that's your number one option, right? RAG's very effective if you've got company data that's not open source and you want to do question and answering or summarization on your company data, then I would use your RAG methods. Fine-tuning is when you need to look at a very specific task, for example, sentiment analysis. Dolly is not really great at doing sentiment analysis. So for example, if you're doing very specific sentiment analysis and you've got enough data to train Dolly, I'd go with fine-tuning. Okay, so let's look at Dolly then. So for the next couple of slides, we will look at how we've used prompt engineering to do a lot of fun stuff, and how we've also used RAG to be extremely productive. And internally as a company, we use Dolly and RAG for question and answering, and it's very, very effective. And the way we do this is by leveraging LangChain. So LangChain is an extremely powerful open source framework that just aids applications. So if you're developing large language model applications, it's a fantastic tool to use. I'm not a developer as such, but I've used LangChain very successfully. LangChain seems to be growing in popularity. When I started using LangChains, you only had very limited components, but that seems to be growing more and more and more. So for example, you've got chains, you've got you've got access to many different large language models. Your prompts are also readily available, so you can leverage prompts to do lots of different things. And you've got many document loaders and utilities, which you'll see how easy it is for us to do RAGs, for example. Okay, so let's look at prompts, and let's look at in-context learning, which often is the way I would start with large language models. And if you wanted to generate something, or generate an output, I'd always try with zero shot. And I'm sure everybody here, or maybe most of us, would have tried using ChatGPT, and where you put in a description and you get a prompt out of it. Those are the things. What you're doing with ChatGPT is called zero shot. Then you've got a more advanced technique called one shot, where you are actually predicting with an example. So what you're doing here is saying, right, I would like to translate from English to French. But you're going to tell the model, this is what I mean by translating. So you've got an example there that you're providing the model. And the model then takes that example, learns from it, and provides an output. Going on from one shot, you've got few shot examples where now you're demonstrating to the model that you've got a couple of examples here, and you would like the model to predict using those examples. So this is a true story. One of my friends, she was starting a business, and she wanted a really catchy name in terms of generating a business name, and she was selling socks. So I said, right, let's use prompt engineering. Let's use zero-shot method. Here I'm using Dolly, which is the 12B model, and I'm using LangChain's prompt template. And I've said, right, in the prompt template, as you can see, I want you to act as a naming consultant for new companies. provide a catchy and creative business name idea. I don't want one suggestion, I want 3 suggestions here. So what I've done is used Hugging Face pipeline. I've pulled the model down, and very quickly, I think was that in 8 seconds, I've got 3 recommendations from Dolly. I think they're quite good recommendations. You know, we've got Good Socks Company, Unit Socks Company, and Funny Socks Company, and that's all generated using Dolly 2.0 model. One other thing is generating recipes. This was something fun that we did, but again, we've spoken to companies out there who are generating, who are working in industries that they would like to look at more generating better recipes. And again, right, you could use Dolly to do this. So here I've given keywords, I've given 5 ingredients that was in my fridge that particular day, and I've said, right, based on those 5 ingredients, generate some recipes for me for kids under 12. Again, using Dolly, I've got a pretty decent response, right? It's not perfect, but I think it's decent, and there's something that we can build on. In fact, with the recent acquisition of Mosaic machine learning and MTB models, you can achieve far better outputs than what Dolly has provided here, but I think it's a fantastic start by Dolly. So we've looked at 0-shot prompts, but what about few shots here, right? Few shots is where I'm now telling Dolly, I've got examples here, and I want Dolly to look at my example, learn from it, and follow. So here, what I'm trying to do is sentiment analysis, and I'm giving examples here saying, ice cream was good, sentiment is positive, and then I gave another example where the sentiment was negative and the sentiment was neutral. Using, again, LangChains and prompt templates, I can very quickly set this all up using Dolly and ask Dolly to generate and do sentiment analysis for me effectively. So in the next slide, that's my input into my previous slide, where I'm saying, okay, that was horrible. Dolly, go away and tell me what that sentiment is, and the sentiment comes back as negative. So you can do quite a bit using few-shot examples and using LangChain's prompt templates to achieve quite a lot. This is another thing that we, as a business, we're trying to look into now as well, generating synthetic data. This is very, very powerful. Using LangChain, we can do this quite easily. You use a few-shot prompt template, and with a little tweak, what you can do is generate synthetic data. And again, you know, I'm sure everybody in here appreciates how data is really important in terms of developing an accurate machine learning model. Using few-shot templates, we've generated lots and lots of synthetic data to complement and augment into our data set. And there's lots of benefits, right, in synthetic data. If you are also working in a regulated industry and you're working with sensitive data, this method is brilliant in terms of generating synthetic data, so you're not using PII data. Okay, this was also something fun that we do as a company. How would you generate blogs? Here, what I've done is I've been a bit clever. So instead of using prompt templates, I've used LangChain sequential chains. So what I've said in my first prompt is, I'm a content creator. If I give you a topic, come up with a creative title. And what I want to do after that step is say, given the title, I want you to write 3 sentences for me. And again, all this is done in LangChain, in Databricks, using Dolly. And what it does is it uses the sequential chain very easily, very quickly, and generates a couple of sentences and also a title of a blog that I was writing, and all I had to do was prompt it with machine learning. So you can achieve quite a lot using sequential chains as well. And if you haven't played with sequential chains in LangChain, then go ahead and play with it. And those were all the kind of different fun things that I've done using Dolly. But we've also done productive things with Dolly. And this is something that we've created for our internal use in advancing analytics, where we've got enterprise data sources, And what we want to do is use Dolly to do some question and answering on top of our private data. So what I'm going to go through is step by step in terms of how, if you're interested to implement this in your organization, how would you go about it? And I've got a couple of snippets of code as well along the way. But firstly, let's just talk about the whole process in terms of what's happening. If you've got many PDF data and they are your company's private data, what you typically do is load the PDF data, again using LangChain, and extract the content from your PDF data. Now, Dolly has a token limit of around 2,050 tokens. Each token translates to about 4 characters in English. So what that means is if you've got a large document, you're going to be hitting limits. But using LangChain here, what we can do very easily is chunk up your documentation into different segments. And then what we do is, using those chunked up sections, we'll use embeddings. And embeddings are a way of converting your chunked up documents into a numerical representation that your computer understands. And what it will do is understand context, so it's not fuzzy matching. It will actually understand context, which is extremely powerful. Then what we do is, once we embed our chunked up data, we will put it in a vector database. And here it's also called knowledge database. They use interchangeably. And what happens then is, say, for example, I'm a user and I want to know what the summary of important documents were. I will come into my application here. I'll put in a question, and it goes through the same kinds of process of chunking up the document and embedding. And what it does then is semantic search, which it does a similarity search in terms of, this is my question, and this is what I've chunked up. How similar are those? And that gets transferred to my large language models, and then it provides an answer back to me. So we'll go through this in terms of how I've done it using LangChain and Databricks. And LangChain makes this extremely feasible, right? So the first step, we want to load and extract text from our PDF. That's a snippet of code that I've used to do this. So I'm using a PyPDF reader. I'm extracting all my text from my PDF and storing it. My second step then is to split my text into separate chunks. Here we've got options, right? So what I've done here is I've chunked it up by 1,000. And a good rule of thumb is to have a chunk overlap of 20% of your chunk size. And the reason we have a chunk overlap is to make sure our context is conserved. So for example, if you don't have an overlap and you've got a sentence ending, if you didn't have an overlap, it won't understand your context. But if you're having an overlap, it will understand that context a lot better. But that is something that you can play around with. People have tried 10%, but rule of thumb, 20% works really, really well. Once we do this, we then are going to store our embeddings. We're going to put it into embeddings. And to do this, I've used OpenAI embeddings here, and I'll tell you the reasons why I've used it. And in terms of vector store, I've used FIS. But again, with LangChain, you've got options to use many, many different vector stores. And yeah, so what I've done is I've embedded it. And this is what I wanted to share with you. There are lots and lots of embedding models. And the way to have a look at how performant embedding models are is to go onto the Hugging Face website. And that's a kind of leaderboard in terms of how performant embedding models are. I've used the OpenAI other embedding model, but I've also tried the InstructXL embedding models. The problem with InstructXL embedding models is you need a GPU to run it. So that might come as a blocker for some people that do not have GPU access, right? But it's a fantastic model to use. So if you have GPU access, I would highly recommend reading this paper about InstructXL and using InstructXL as an embedding model. Just wanted to touch on vector databases. If you're using LangChain, that has now since grown. You've got options to many other vector databases. For the purpose of this talk today, I've used FAISS. FAISS was developed by Facebook researchers, and it works pretty well. So just going back to our process in terms of how we've done this right, we have chunked up our text, we've embedded our information that we've chunked up, we've put it in a vector database, and the next step is then to put it, well, we're using LangChain here to do question and answering, and what we're going to do is stuff all our documents into a large chain and then do a similarity search. If you're implementing this and you come unstuck with the chain type stuff, if you run into memory errors, there are many different options that LangChain have come up with. I'd recommend using MapReduce if you're hitting memory errors. And what MapReduce does is, instead of taking all your documents and stuffing it and doing a similarity search, it does it more intelligently. So this is an example of what we do, actually, or how we use our AI-powered question and answer system. What I've done is I've asked the Dolly to provide me the top 3 use cases for a survey that we wrote as a company. And what Dolly has done is it's gone and done a similarity search from the large document and provided us with the answers. So that's the top 3 use cases that's coming up from the survey. And you can do lots of different things. You can do summarization as well. And it's extremely, extremely useful. We use it on a daily basis. So if you're intending to implement this, please do. We're using LangChain. It's extremely simple. What we've done is we've gone a step further, right? So what we've done is using Python and Streamlit, we have deployed a Dolly web app. And this is just for internal use. So this should be a video that's running where we can talk to any PDFs that we have, any links. And what we've done here is created a web application that we can throw in a PDF where it gets embedded automatically, and you can ask any questions. Example there, I've been typing out, recorded this. You can ask questions, and it'll go away. It will do the similarity search, and it'll provide users with a response. You should see the response in a couple of seconds. Now, I'm not running GPUs when I've built this application. I'm running it on CPUs. So if you are noticing the lag in terms of the video, it's because I'm not running on GPUs. If you're running it on GPUs, definitely you get better performance. Should see output, but it's no output at the minute. I'm not sure why, but yeah, it definitely does come up with a response. Okay. So often we get asked this question, right, in terms of if you've got an LLM model, how would you use it for a task that you have? And the advice that we always would give is to start with prompt engineering, start with in-context learning, start with very simple zero-shot learning where you're asking it a question, see whether you like the response. If you don't like the response and if you wanted it in a particular way, try your one-shot and few-shot methods. If you're not getting the right response after doing your in-context learning and using prompt engineering, look at fine-tuning your data, where you're going to have to prepare and upload your training data, and you'll go through the motions of creating a model that's very specific. I said previously when I started this presentation, I'm not going to go through fine-tuning, but I've looked at this particular resource, and it's a fantastic resource where they fine-tune Dolly using LoRa, which is your low-rank adoption for large language models. It's a very efficient way of tuning Dolly, and I think that video is only 15 minutes long, so it's not overly complicated. So if you're looking to fine-tune your data, have a look at that resource. Another question we get asked is, in terms of LLMs, and if you've got highly regulated business, just understand in terms of if you're trying to not use Dolly, but if you're trying to leverage other open source large language models, make sure that they adhere to your Apache 2, your MIT GPL, because these are all suitable for commercial use. Anything else, you're possibly going to get into trouble. So just check in terms of if you are regulated and you need it to be open source. These are the licenses that tend to be acceptable. What are some alternatives? We often get this as well if you're not getting results with Dolly. I'm quite proud of this slide because you probably notice your MPT recommendation bias. This was done before I knew that Databricks was going to be acquiring Mosaic, so I'm quite pleased about that. We've tried Mosaic models. They're fantastic models to use. So if you're not getting anywhere with Dolly, I'd highly recommend using your Mosaic models. What I particularly like is your MPT 7 billion story writer model. They're just fantastic. But there are other models out there that are extremely suitable for commercial use, and they're open source as well. One thing I have found extremely good is this particular website. It's called Chatbot Arena. This was before they're starting to develop evaluation large language models. And this particular website allows you to compare different LLMs. So here, for example, I've recorded a video where I've gone in and I've compared a Dolly 12 billion model against an MPT model, as is also coincidental. And I've asked the model to write me a complaint letter. And this is fantastic. I mean, when I was sitting down and recording this video, I honestly thought the MPT model outperformed Dolly, the 12 billion Dolly. It's a bit small for you to read, but I'd urge go away, look at this website and try it out yourself. You can try many different things. You can even try summarization, generate many different things, and you can have a look at how each model performs side by side. If you're wanting to get started, I'd just look at DB demos. There's a fantastic demo by Sean Owen where he talks about how you do question and answering, how you develop your own chatbot using Dolly. I've learned a lot from just using these demos. And if you have any questions, come and talk to me. And that's the end of my talk. Yeah, I'm happy to take questions.
Raise your hand and I'll come around. I'll go over there first.
Hi, thanks for the talk. I was wondering, in building your Q&A system for internal use, will data privacy become an issue in any of the steps in your workflow? Like, for example, when you're generating the document embeddings, will the data be seen by third parties?
No, it's all stored locally.
Okay.
Thank you for showing the great example for the PDF retrieval. So I have a question about for that, because our use case is more like for the numerical data and tabular data within the PDF.
Yep.
So we want like accurate answer from that Q&A engine. So does that vector or indexing mechanism work for like specific tabular data?
It goes back to your LLM. So Dolly isn't great with tabular data. So you probably have to use something a bit more suitable that would understand that. It doesn't, so your embeddings won't affect that really. So it'll be your LLMs. And yeah, try it. We've tried it with many different LLMs and it works.
So do you think the embedding also matters? Because that's their, right?
We didn't see an issue, so we had tabular data as well in terms of understanding in terms of revenue, what we did last year compared to this year. We didn't have an issue, it picked it up fairly accurately.
Cool, yeah, thank you.
So when we do tokenization,
yeah.
Is it just a trial and error as to the size of the token that I'll be using?
Yeah, so the reason why I chose 1,000 because I knew Dolly was the limit of Dolly was 2,000. So yeah, I could have chosen 500. I could have chosen 1,500. Sure. So it depends on if you're using another LLM, for example, your MPT models, they've got a larger tokenization limit, so you can go with a far bigger number.
So mostly it's trial and error.
Yes, it is. Yeah.
Okay.
Yeah.
The other question was, like, right now, we are still waiting for Databricks to come to our environment.
Right.
Can we run this outside of Databricks for the time being?
Yeah, absolutely. Because Dolly is hosted on Hugging Face Hub, you could use it, for example, if you're using Jupyter Notebooks, you can connect to it, pull it down, and use it that way.
Oh, great. Thank you. And this will be on-prem, or it has to be on the cloud?
Sorry?
Can we do this demo on-prem?
Yes, yes. So we have deployed it in GitHub for our internal users, but you don't have to do that. You can store it locally and not deploy it onto the cloud.
Thank you. Thank you.
Two questions for you.
Yeah, sure.
The first one relates to the couple questions ago.
Yep.
To incorporate relational data into things where you want responses.
Yeah.
So you want a synthesis of relational data and your prompt and your context.
Yeah.
What's the best approach to doing that? Do you bring it in the same way that you would in a RAG, or do you chain models?
I think there's many different ways. The first method I probably try is bring it in, retrieve it, augment it, and then see what happens. I'm not sure how you would do it with chains, really, because even if you chain it, you still need to embed it.
Yeah.
So I would go with the RAG method first.
And then when you embed, you just embed it as, you give it some format. You say, this is the format to expect it in.
No, not at all. It does it for you. So you just see that line before, right? Let's go back for a bit. Is it going to be quite a lot? Oh, I can show you in a bit.
Sure, yeah. I'll give them afterwards.